record. So 3.4 simple rational function worksheet. We're doing question F. It said for each function, find the equation of any vertical asymptote. So vertical asymptote is restriction for x, you know, a vertical line. See, vertical line is like that, right? Is x equal to a constant number? It means this is your restriction. So the restriction happen at denominator. Here, the denominator cannot be what? What number?
0.
0. So we have a vertical asymptote at x equals to 0. We have an slant asymptote 2x, but we don't need to talk about that. Just x equal to 0 will be your vertical asymptote. Okay.
Yeah.
Now question number 3F. We say find derivative of each function, then determine whether the function has a local extreme. So to find a local extreme, you know, you set your derivative equal to 0 because at maximum point, your instantaneous rate of change is 0. So you have to find a derivative. So let's just do the derivative here. This is t prime x. Make sure you know which question is that. So this is using the quotient rule, the denominator power 2. So 3x2 plus 12x power of 2. So the derivative of numerator 2 multiplied by denominator without any change. 3x2 plus 12x. Now your numerator will be minus numerator without any change. Multiply by derivative of denominator is 6x plus 12. Here, see, I can factor out 3. I can factor out x, right? So let me just do it with different color. I can here I can factor out 6. It become what? 3. It can become x plus 2. And from here I can factor out 3x. So it's gonna be x plus 4. Now from these two terms, 2 multiplied by 3 is 6, right? So I can factor out 6x. If you factor out 6x here, you just have x plus 4, right? And you factor 6x here, you just have 2x, which is negative. And you can have 4, right? Minus 4. So, okay. So I just put that, means it's repeating. It's 6x. I just want to make sure I'm doing that right, guys. So here, yeah, this is gone. It's going to be 2x. Okay, so here is just going to be negative x. 4 and 4 is canceling. So it's negative 6x power 2 divided by 3x2 plus 12x. So that's a tricky one, right? We have the zeros, but it is very important that the sign around the zero become change. See, here is going up, so that is the slope is positive, means the first derivative is positive. And then the first derivative here after that point is negative. Because the sign of derivative need to change around that point. When you find the sign of that, you find the zeros in numerator and denominator. In denominator, we have zeros as well, right? Which is, if I factor out 3 is 3x, it become x plus 12, right? That is x plus 4.
4, yeah.
And I put that in a, so we have 4, 0, -4. You can cancel these x's, x power 2 and x power 2, true?
Yes.
X power 2 and x power 2 can cancel, and just we have -4. But -4, this is your second derivative is 0, but if you put a test point, like 0 is your test point, and here is -5. If you put 0 here, so make sure this and this one is gone, then you take it out. If you put -5 here, the sign gonna be negative for your secondary. Also, if you put 0 here, again, the sign gonna be negative, right? The reason is that because x plus 4 is the power of 2. So power of 2 of something is always positive. Doesn't matter what is the x plus 4, is it negative or positive, true? Because you see at -4, we do not have any, it's not gonna give you actually anything. Even if you had x power 2 in numerator and we wanna find the sign around that, the sign wouldn't change because this is power 2, right? It's always positive.
Yeah.
So we don't have any extreme here.
Okay.
Good.
Yeah.
Sorry. Again. Share.